In order to find arc length, we will need to integrate from x equals -1 to x equals +1. And then for arc length, we need to take the derivative, which for this is going to be just simply x once you multiply the half by 2. So the derivative is just x. The formula for arc length says integrate 1 plus that derivative is squared. So this is what we're going to be integrating. This is actually a pretty challenging integral, so what I'm going to do is I'll come back to this. What I need to do first is cover how do you integrate secant cubed. Well, this is done by using integration by parts. What you do is begin by factoring secant cubed as secant squared times secant. And then for integration by parts, the secant squared is actually going to be dv, and this is going to be the u. So we've got u is equal to secant of theta, dv is secant squared theta d theta. Take the derivative over here, so the derivative of secant is secant times tangent. And over here, integrate, and you will get tangent. All right, for integration by parts, it says multiply the u and the v, first of all, and then integrate the v du. So we would have the u times the v is going to be secant of theta times tangent of theta, and then minus the integral of v du is going to give us a tangent squared times a secant. Alright, now for integrating secant times tangent squared, what we do is replace tangent squared with a trig identity secant squared minus 1. And then distribute this secant. So we would get secant cubed and minus the integral of secant. Except we're actually going to have a negative and a negative. This last one is actually going to become a positive. So we've still got this secant of theta, tangent of theta, minus, and then this, when you distribute, is going to become the negative integral of secant cubed. And then negative, negative makes plus the integral of secant. Okay, now notice that the problem that we were working on, integrate secant cubed, actually showed up again. So this happens with integration by parts sometimes. What you do is treat this as one big equation. So it says integral of secant cubed equals all of this stuff. Just take this, move it to the left side of the equation, in other words, add the secant cubed to both sides, and then we'll have two of them. So then we'll have 2 integral of secant cubes on the left-hand side. On the right-hand side, we've got this and the integral of secant. So we've got secant of theta times tangent of theta. And then this one, hopefully you know, is the natural log of secant plus tangent. And it's so plus the natural log of secant of theta plus tangent of theta. Okay, one last thing is we need to get rid of this 2, so multiply both sides by 1/2. So the integral of secant cubed is going to be 1/2 secant of theta times tangent of theta. plus the natural log with a 1/2 in front, the natural log of secant of theta plus tangent of theta. And then technically we would have plus c. So now let's do this integral. Well, with this, because it has the sum of two squares, it's a good idea to use trig integration. So set up a triangle. Because the two sides are being added together, these two are being added together, then this can be x and this can be 1. Use the Pythagorean theorem to find out this would then be 1 plus x squared inside of a square root. And then if you use this side and this side, you would find out that tangent of theta is equal to opposite over adjacent. We could then take the derivative to find out what dx equals. So the derivative of tangent is secant squared of theta d theta. And we also need to find out what the radical is equal to. So I'm going to use this side and this side. Well, if I used adjacent over hypotenuse, that would be cosine. But if I inverted that, inverting cosine is secant. So by inverting them, I would have the hypotenuse over the adjacent. Okay, so it's ready for the trig substitution. The radical gets replaced with secant of theta. This d theta was not supposed to be there. That one has the d theta. And so we would have integrate. The radical is the secant of theta. The dx gets replaced with secant squared theta d theta. And that means we need to integrate secant cubed. So that's why I did that before. So previously what we got is that's going to be 1/2 secant theta tangent theta plus another 1/2 natural log of secant of theta plus tangent of theta. And in here I don't put plus c because I am going to have numbers to plug in once I get back to the x system. So I need to replace these trig functions with their algebraic counterpart. So the secants get replaced with the radical, the tangents get replaced with just x. So we've now got 1/2 the radical 1 plus x squared. The tangent is an x. And then 1/2 the natural log of the radical 1 plus x squared plus replace tangent with an x. Finally, put the limits back that x ranges from -1 to +1. So we would first substitute the 1. This would be 1 squared plus 1, so that's a radical 2. I should have parentheses just to emphasize the 1/2 times out. So this is going to be a radical 2 times a 1, and then times a half. So that's radical 2 over 2. And then for the natural log, this is going to again be the square root of 2 plus a 1. So we'd have plus 1/2 the natural log square root of 2 plus 1. Alright, now substitute in -1. So this part is going to remain the same when you square -1. This is still going to be radical 2, but because of this, it's then going to be negative. This part is going to remain the same. This will be radical 2, but then subtract 1. So then we've got plus 1/2 the natural log, and then radical 2 minus 1. Let's see if we could combine. So here, this is going to be positive radical 2 over 2. Here's another positive radical 2 over 2, so that's 2 of them. So we've got radical 2, and then 1/2 natural log. So in here, we've got this, and then we've got minus this. Normally what I would do at this point is just put these numbers in the calculator. But instead, I want to show you one other little thing. I know this has been a long video, but one other little thing that students say, hey, the answer in the back of the book is so much different than mine. Well, I'll show you what they often do. They use the rules of logarithms to say, you know what? This really means a 1/2 exponent. So I'm going to move that up here. So 1/2 exponent means square root. So we'd have the square root of the square root of 2 plus 1. Isn't that lovely? Minus, do the same thing over here. So natural log of the square root of 2 minus 1. And then there's one more rule with these being subtracted. You can turn this into one logarithm. And then it's going to be one big fraction, this divided by this. And that loveliness is our final answer.